In the last tutorial here, we're going to go ahead and describe the code, the sketch that was used to make this walker happen. This came from the Instructables website, so if you would like to go there, the link is on the web. It's very short. You'll see it's about a dozen lines long. So initially we have to define some variables. So we're going to be using the servo library, which are the servo commands. We want to define our servos. So servos are going to be our front servo and our back servo. So we have to include that in our code. And then what we're going to do is we're going to define a character forward. The brackets means that it's a list. This is going to be a list of positions that the motors will go to. Position 60, 100, 100, 100, 100, 60, 60, and 60. Now, the numbering system for the list starts with n equals 0. It doesn't go n equals 1, 2, 3, 4, 5. You'll notice there are 8 numbers. So it starts with n equals 0 and it goes to n equals 7. So we have to tell the Arduino where our servos are connected. And so within our void setup, which is this little loop here, now it's actually a little defining a set of definition lines, we're telling the Arduino that our front servo is attached to pin 9, and we're telling the Arduino our back servo is attached to pin 10. Finally, this is our infinite loop. This is our do loop. So for numbers n between 0 and 4, okay, actually 0 and 3, you'll notice that n is less than 4, but not less than or equal to 4. So for n equals 0, 1, 2, and 3, the front servo will go to position 2n, the back servo will go to position 2n plus 1. Right basically tells you to send the front servo to the position within the right field, but the forward of 2n refers back to this line up here. So, for example, where n equals 0, we go to, the front servo will go to position right of forward of 0. Forward of 0 is 60, so it'll go to position 60. When n equals 0, the back servo will be at position forward of 1. Forward of 1 is the first 100 here. So it'll go to position 100. And it'll do this, it'll cycle from 0 to 3, 0 to 3, 0 to 3, 0 to 3. The delay here tells you how long you wait to execute each of these lines. So with the delay of 100, for example, you'll notice the speed at which this device functions. If we set the delay to a larger number, these units are in milliseconds, by the way. We change this number to, say, 500 milliseconds. Compile. Upload. Notice the device is stopped. And the device moves much more slowly. Keep in mind that you can't make this thing infinitely fast. The motors can only move so fast over a certain distance. Finally, as a final note, this is something that I won't demonstrate, but I can leave this as an exercise for those that are interested. If I wanted to change, for example, if I didn't want the arms, the front legs, you can see them the way that they're swinging. If I didn't want them to swing so far, I can actually change some of these numbers. Well, let's actually demonstrate that. So what we've done is we've changed the numbers. You'll notice what we did in order to change the range over which this thing will move. In order to decrease the range over which the front legs will move, you'll notice the forward legs here are all the even numbered spaces. So we increased the 60 in the space 0 to 70, decreased space 2 and equals 0, and equals 1, and equals 2 from 100 to 90, and then went to the next even one, 100 to 90, and the next even one, 60 to 70. And you'll notice, I don't know if I can get it in here, front legs don't move quite as far. Now I'll change the back just to show you once again that this works. Okay, now we've put the numbers back to where they were. Hopefully you can see that there's a wider range of travel for the front legs. Keep in mind that these position settings are angles. Okay, so if you want to keep this thing symmetric, 100 degrees is the maximum position, 60 degrees is the minimum position. So if you wanted to decrease its range, you'd have to take the smallest number and add 10 or some number of degrees, and you take the largest number and subtract that number of degrees in the present case. Of course, this depends on your configuration.